Hi, Ms. Navickas.
Hello.
So we determined that water was essential for life. Living things need water. And even scientists are traveling to other places in the universe and planets looking for water. And that's one of the conditions that water is important for life. And that's one of the clues that they're going to try to find living things is connected to that. So what makes water so special? Like, what is it about water? And you know, when you look on Earth, water seems to be the only liquid, right? I mean, I look around me, the pen is solid, the air is gas, the chair is solid. I'm pretty solid, although I know there's water in me, because, we need water. But water seems to be like the only liquid on Earth.
Right.
And maybe there's oil in special places, but that's not that common, So is all water the same? I mean, let's take a look at some different. I want to do an experiment. We want to follow the scientific method, which is, understanding how to set up an experiment. We have independent variables, we have dependent variables, we have constants, and what I have over here are 3 cups of water, and each one is different, but Miss Navickas does not know which one is different, and I want her to use her senses of taste to see, do they seem the same or do they seem different. We want to test the different qualities of this water and learn a little bit about that, some of the properties of water on Earth. And when we do labs this year, we can think about the water that we get and what that means. Okay, so the first thing we do when we set up an experiment is we need to make sure that we're holding things constant. And so what is it that we need to do to hold things constant?
All of the water that's in cup 2 is the same. All of the cups 2 have the same water in them. All of the water in cups that are labeled 3.
When you say the same, so do we need to make sure that we measure them in such a way that we have the same amount in every cup?
Exactly.
And okay, so how will we do that? Let's come up with a scientific method to agree upon a certain amount to put in every cup. So this is a graduated cylinder. It's very precise for measurements. Got little fine lines. So why don't you measure 20 milliliters, and I will get the other cups for you, and we'll pour them in, and I will get you a pipette in case you go over or to under.
Okay. So as we can see on the graduated cylinder, 20 milliliters is about right there. So what I'm going to do is take this graduated cylinder is labeled 2. What I'm going to do is take the water that's in cup 2 and start to pour. Make sure that you're at eye level so that you can see.
Looks almost perfect. Awesome.
You can see that it's just at the line labeled 20.
So she didn't need a pipette. Sometimes if you go over, you could just take the pipette and just take a little bit of water out.
So now I'm going to pour the water that's in the graduated cylinder into my little cup.
I noticed we're really careful to make sure that what's labeled 2 on the graduated cylinder and that was on the cup number 2, they all line up so that we don't mix up the different solutions, and otherwise our experiment would be invalid.
Right. So now I'll move the cup and the graduated cylinder away so that I don't get confused now when I pour the waters from cup 1 and cup 3.
So are you going to do the same sort of thing to the second cup?
I will take the same amount of water from this cup and use the graduated cylinder labeled 1 for the cup that's labeled 1. And the line for 20 is about right here. So now I will start to pour.
And if you really want to be careful, she could always take a little water like this and slowly add it till she reaches 20. How did you do there? Oh, you're really good at that.
A lot of practice.
So now are you adding it in the same size cup and the same type of material?
Same size cup, just labeled 1. That's the only difference.
And it's plastic, just like the other one, so it's not glass. So we're keeping the materials the same in the other setup. So we're holding things constant. The only thing that we're changing is the type of water that's in the cup. Right. So she's got one more water to pour. Here you go. She's going to follow the
Oh,
similar
a little.
technique. Oh, I'm sorry. I need to get a little cup. Thank you. I need to stick there. Here you go. Here's your little cup 3. So if we're changing only the type of water and everything is the same, then the first thing we're doing is changing the type of water. What's going to be the independent variable in our new experiment?
The independent variable will be the differences in the taste of the water.
I think you just made a mistake.
Did I? Oh,
Yes, you did.